It's Thursday, April 30th, and this is Nighttime Mathematics Radio. The show always works the same way. You tweet your questions to @NightMathRadio, and I'll try to answer them right here live on the air. So, it's a quiet sort of Thursday night. I've got one question queued up about units, and after that, we'll answer any questions that come in over the internet. So, tweet your questions. We'll take a quick break here while people have a chance to tweet in. Then we'll go on with the show. This is Nighttime Mathematics Radio. Welcome back, everybody. This is Nighttime Mathematics Radio. Well, it looks like it's a quiet night on Twitter, so we'll do a quick talk about units, then we'll end the show, unless somebody tweets in. So, what are units? What are we talking about here? Well, in real-world problems, these are the word problems that we talk about all the time. Numbers aren't just numbers. You don't just have 5 in a word problem. You have 5 of something. You have 5 pounds per square inch, or you have 5 people, or you have 5 miles, or you have 5 inches, or you have 5 millimeters. But you have 5 of something is the point. And what that something is really important. It turns out there's a way to handle units which can actually help you not get problems wrong. So let's talk about that. Now, you could, suppose, for example, you have some function which represents the number of items somebody buys based on the price. So we could call this, say, the demand as a function of the price. And so the question is, what units are this in? And the answer is it's in whatever items these are. Say it could be items. The point is that this is a number in items. So if you know the demand to say is 6 items, you should say 6 items. What happens if we divide that by price? Suppose I have, say, if I change, I can sell 2 more items if I cut the price by $1. Well, the answer is there's fixed rules about what happens with units when you're adding, subtracting, multiplying, or dividing. What are these rules? If you're adding and subtracting, you can only do that with quantities that have the same units. So adding, subtracting, multiplying, and dividing, that only happens if you have exactly the same units. Why? Because fundamentally adding and subtracting are versions of counting. I mean, fundamentally where adding comes from is counting. So if you have, say, 6 gallons of something and you want to add 3 more gallons, you can only add those and say you've got 9 gallons if everything is gallons. What happens if you're trying to add things of different quantities? Well, there's two possibilities. Either you have a way of converting one unit into the other, or you have to do that before you can add or subtract. So, for example, if I say I have 4 quarts plus 6 pints, I can't just add that to get 10 because that's not 10 of anything specific. What can I do? Well, it's 2 pints to the quart. So I can convert units. I'll talk about that in just a second. So let's hang on to this, and we'll come back to it in just a second. How about if you're multiplying? Well, you can do that, and you end up with a new unit, where anything that was in the numerator multiplies together, anything in the denominator multiplies together, and the fraction you say using the word per. So, for example, if I have 6 gallons divided by 2 hours, then what I have is 3 gallons per hour. You still write it using the division symbol, even. I mean, you could write GPH, but that's sort of ugly. Or if I multiply, or I can multiply 3 centimeters times 6 seconds. And then what I get is 18 centimeter seconds. That's centimeters times seconds. What's a centimeter second? Well, I don't know. And if you don't know either, you probably did something wrong. This is the advantage of being careful with units. If you're careful with units, if you write them in every line where you have numbers attached, and you carefully follow the rules of adding, subtracting, multiplying, or dividing units, if you make a dumb mistake, if you arrive at a formula that can't possibly be correct, the units will tell you that because you won't be able to actually do the computations that you write down. This is why you always want to keep units whenever you can. So let's go back to this pints thing. You can actually, if you think about what a unit conversion is just a ratio. It's, 2 pints per quart. Or 1 quart per 2 pints. That's just a fraction. And I can multiply it here. Why can I multiply it? Because those are the same thing. 2 pints is the same thing as 1 quart. 1 quart's the same thing as 2 pints. So those fractions are all 1, and I could always multiply by 1. So if I have my problem I was stuck on before, by 4 quarts plus 6 pints, I can multiply that by 1 quart over 2 pints. And notice when you do the fraction math, this is 6 pints over 1, the pints cancel. Because pints follow exactly the same rules as any variable. So you end up with, that divides out to give you a 3, you end up with 4 quarts plus 3 quarts. And now the units are the same, so now you can add. So this is the biggest reason why, whenever you possibly can, you should keep units in your... You keep units in your calculations, because the units can tell you if you're doing things right or wrong. So what's the moral of the story here? Whenever you can in word problems, keep the units in place. Yes, they look annoying. Yes, it would be faster to write if you didn't. But as long as you keep the units in place, you can keep track of what's going on. You can avoid making lots and lots of dumb mistakes. And there's two things. One of the things will happen when you make a dumb mistake. Either you'll end up with an expression that you can't add. You'll end up with 6 meters plus 3 cups. And the answer will be, okay, something's wrong with my math. I should check my algebra. Or you'll end up with an answer in a unit that doesn't make sense. You'll end up with 3 centimeter seconds per volume. 3 centimeter seconds per, 3 centimeter seconds per kilogram. And you'll say, what's a centimeter second per kilogram? And the answer is, I don't know, but it can't possibly be the answer to this question. This is also the reason, by the way, why at the end of a math problem, you always want to write out your answer in English. Because when you get to the end, when you get your units in place, if you write your answer in English, besides the fact that it's just polite to answer a question that was asked you in English, your answers to word problems should always be real world and not sort of automatic. So your answer to a question like, what's the furthest you can get for this balloon shouldn't be, 8.7. It which would be you can get at most 8.7 meters from the balloon, or something sensible. But also, if you've kept your units carefully through the problem, when you go to write your answer in English, it will become really obvious that you've made a mistake. That is, if you write your answer and you say, and the question is, how long will it take to travel this distance? And you say 15 miles. That will give you a chance to say, wait, I don't think that's right. And that's really helpful in a lot of cases. This is Nighttime Mathematics Radio. Well, it's a really quiet night on Twitter. No one's asking any questions, so I think we'll end the show right here. Feel free to keep tweeting questions to @NightMathRadio. Come on back tomorrow. We'll have another show. So in this weird world where all the classes have stopped, but the homework goes on and on and on, just keep tuning in. I'll try to help you out. Good night, everybody.